So in previous sessions we have discussed about number system conversions like binary to decimal, decimal to binary, octal to hexa, like that conversions we
या
have discussed. And
भैया इसमें
mm,
इस भैया इसमें ज़्यादातर इंटरव्यू मतलब कि ये जो नंबर सिस्टम है उसमें कैसा क्वेश्चन पूछते हैं? ज़्यादातर इंटरव्यू चाहते हैं कि इसमें बच्चा फंसे,
mm,
तो वो लोग मेरे ख्याल से ज़्यादातर हेक्साडेसिमल का, मेरे से एक बार मैं इंटरव्यू दे रहा था तो मेरे से हेक्साडेसिमल का ये लोग क्वेश्चन किए थे। तब
yes,
मैं डिजिटल इलेक्ट्रॉनिक्स ज़्यादा पढ़ा नहीं था तो मैं नहीं जवाब दे
that
पाया।
is a wrong thing we will do. Like we will neglect digital and we will study all the higher subjects, but they will go into the basics only.
या
Mm. So basics should,
इन
fundamentals should be
ये
very
नंबर
strong.
सिस्टम
Mm.
ये नंबर सिस्टम में मतलब कि ज़्यादातर मतलब हेक्साडेसिमल ऑक्टा किससे पूछते हैं ये लोग?
Yeah, like they may ask conversions also. Okay, like don't expect many questions from this number systems. They will mainly focus on combinational and sequential only, but
या
learning and keeping it strong is also good.
या ओनली इंटरव्यूअर विल आस्क ओनली वन क्वेश्चन फॉर नंबर सिस्टम।
Yeah. Now let's discuss about basic binary arithmetic. So in this basic binary arithmetic, we will have binary addition, and we have binary subtraction. So we will discuss about this binary addition and binary subtraction. So coming to binary addition, we will perform the addition between two binary numbers. So the rules for this binary addition are, we know 0 plus 0 will be equal to 0, 0 plus 1 will be equal to 1, 1 plus 0 will be equal to 1, and 1 plus 1, the sum will be equal to 0, and carry we will get 1, and 1 plus 1 plus 1 will, the sum will be equal to 1 and the carry will be equal to 1. So this is the rules for our binary addition. And coming to binary subtraction, and coming to this binary subtraction, 0 minus 0 will be equal to 0, and 1 minus 0 will be equal to 1, and 1 minus 1 will be equal to 0, and 0 minus 1 will be equal to 1. Difference is 1, and borrow will be equal to 1. So this is the binary subtraction. And similarly we have also binary multiplication. So in this binary multiplication, 0 cross 1 is equal to 0, 1 cross 0 is equal to 0, and 1 cross 1 is equal to 1. So this is known facts. And we will start with complement of numbers. So we'll start another topic which is called complement of numbers. So let's say we have a number with base b. Say suppose if we have a decimal number 5, then the base of the number is 10. So like that we are taking some number with base b. Instead of 10 we are taking some number base b. So there are two complements for this base b numbers. There are two complements existing for base b numbers. So the first complement is b's complement, and the second type of complement is b minus 1's complement. Okay, so for a number with base b, we have two complements, two type of complements. One is b's complement, and another is b minus 1's complement. Say for example, for decimal numbers, say for octal numbers, the base of the octal number we know that is 8. So the base of the octal number is 8. So for this octal numbers, we have two types of complements. One is B's complement. Here B is nothing but 8. So first type of complement is 8's complement. And we have also called, we have also have B minus 1's complement. That is 8 minus 1, that is 7's complement. So for a given octal number, we have two type of complements. One is 8's complement and another is 7's complement. Now take another example, say for binary numbers. So for this binary numbers, what is the base of the binary number? We know base is equal to 2. So we have for binary numbers 2's complement and 2 minus 1, that is 1's complement. So like this, for any base number, for any base B, we have two types of complement. One is B's complement and another is B minus 1's complement. Here, in case of binary, there are two complements. One is 2's complement and another is 1's complement. And for hexadecimal, we have base as 16. So we have two complements. One is 16's complement and another is 16 minus 1, 15's complement. So is this clear?
Clear.
Yeah. So let's start with discussion of ones and twos complement. So this ones and twos complement is for binary numbers. So this ones and twos complement are for binary numbers. So let's start with our ones complement. So let's take an example, say 0, 1, 0, 1, 1 to the base 2. So for finding the ones complement of this binary number, we will just swap zeros to ones and ones to 0. It's an easy process. So the ones complement of 0, 1, 0, double 1 will be equal to 1, 0, 1, double 0 to the base 2. And coming to, let's take another example. If we have 1, 1, 0, 1 to the base 2, then ones complement of this is simple 0, 0, 1, 0. So this is the ones complement of this given number. And if we want to calculate two's complement of this given number, that is 0, 1, 0, 1, 1 to the base 2, then two's complement is nothing but one's complement plus 1. So we will add 1 to the one's complement. If we have a binary number, say 0, 1, 0, 1, 1 to the base 2, and if we want to find the two's complement, then simply first find the one's complement, that is 1, 0, 1, 0, 0, and add 1 to this one's complement form. Then we will get 1, 0, 1, double 0 plus 1, which is equal to, we will do addition 1, 1, 0, 1, 0, 1. So this is the two's complement of the number 0, 1, 0, 1, 1 to the base 2. So this is the calculation of ones and twos complement of a given binary number. So is this clear, right?
Yeah, clear.
Now coming to nines and tens complement. So nines and tens complement is found for the base 10, that is decimal number. So coming to nines and tens complement, if we have any number, say 2, 5, 4, 8 to the base 10, and if we want to find nines complement, and if we want to find nines complement, then simply subtract each digit by 9. So 9, 9, 9, 9 subtracted by 2, 5, 4, 8. 9 minus 8 will be equal to 1, 9 minus 4, 5, 9 minus 5, 4, 9 minus 2, 7. 7, 4, 5, 1 is our nines complement of 2, 5, 4, 8. So this is the nines complement. So this is how we will calculate the nines complement of a given decimal number. And if we want to find out the tens complement, then simply add 1 to the nines complement number. That is nines complement plus 1, which will be equal to 7, 4, 5 to the base 10. So this is how we will calculate nines complement and tens complement of a decimal number. So is this clear, right?
Repeat once more again.
Wait a minute.
From 7451 ये उसके नीचे का.
Yeah. So 7451 is the nines complement of a given number. So if we want to find the tens complement, then we will add 1 to this nines complement, that is 7451 plus 1, that is equal to 7452 to the base 10. Okay.
Okay.
So this is how we calculate the nines complement and tens complement for a decimal number, and you try finding out the sevens and eights complement for an octal number. I will post a poll also if possible today. So find the sevens and eights complement of a given octal number. Say suppose 7, 3, 6 to the base 8. Find the sevens complement and find the eights complement. This you can do it. So these are the complements of a number, and we have also 15s and 16 complement. If you want to try, you can try it as a homework. 15s and 16s complement. Say suppose if we have a3b to the base of 16, then find the 15s complement and 16s complement. The procedure is same. In case of octal numbers, we will just subtract 8 from each digit, that is 888 minus 736, and we will get the 7's complement, and if we add 1 to the 7's complement, then we will get 8's complement. And in this case of hexadecimal number, we will subtract 16 from each particular digit, then we will get the 15's complement, and if we add 1, we will get 16's complement. So this is how we perform the complements of a number. So is this clear, right?
Yeah, clear.
Wait a minute. Yeah. So now we will start with a topic called number representations. So in binary, there are three ways to represent a number. So there are three ways to represent a binary number. The first way is to represent it using sign magnitude form. And other is ones complement form. Followed by two's complement form. So we will discuss one by one. So coming to sign magnitude form, the MSB represents the sign and the remaining bits are its magnitude. So coming to this sign magnitude form, we will discuss this sign magnitude form. So if we want to represent plus 5 in sign magnitude form, so if we want to represent plus 5 in binary in sign magnitude form, then for plus we will use symbol 0, and for minus we will use symbol 1. So this we should remember. This is mostly used in some scenarios. So plus is represented by 0 and minus is represented by 1. So here if there is plus, then we will use 0 followed by, it is represented in decimal, so equivalent of 5 in binary is equal to 101. So this part is magnitude, and this part is the sign. So that's why this method is called sign magnitude form. So 0 represents the positive sign followed by 101. If we want to represent minus 5, then for representing minus, we will use 1 followed by the magnitude. So this is the sign and this is magnitude. So this is how we can represent plus 5 or minus 5 or any positive or negative numbers using sign magnitude form. So this is how simulator also stores the binary uh, this is how the simulator also stores the positive and negative numbers. If we want to store minus 5 in a computer, then then the simulator will or the compiler will convert this into binary by converting it into any of the three forms. It will convert it either into sign magnitude form or ones complement or two's complement, and it will store it into system. So this is the conversion process and it will store it. So if there is a binary number represented in sign magnitude form, I am mentioning here that the binary number is represented in sign magnitude form. Say suppose 0 1 1 0, I am mentioning this, it is represented in signed magnitude form. If I have not mentioned this, then simply it is equal to 6, but I am mentioning it is represented in signed magnitude form, so this is equal to plus 6. And I'm mentioning if it is represented in signed magnitude form, this number is represented in signed magnitude form, then this is equal to minus 6. And if there is a number 1110 and if I am not mentioning in which form it is stored, it is represented, I'm not mentioning this number is represented in signed magnitude form, so you can simply write 8 plus 4 12 plus 1 13. But I'm mentioning it is represented in signed magnitude form, then it is not equal to 13, it is equal to minus 6. So be careful in this representations. So is this clear for everyone, right?
Yes.
Yeah. So there is a disadvantage of this signed magnitude form. So let us discuss this disadvantage also. And with this disadvantage only, we are moving to other form of representations. So we know that in number representation, we have positive numbers, so on, and negative numbers, so on to some minus 1, minus 2, minus 3. So we have negative numbers followed by positive numbers. There is nothing like a plus 0 or minus 0. There is only simple 0. But if we want to try to represent sorry, so in sign magnitude form, 0 has two representations. 0 has plus 0 representation, like we can represent 0 in sign magnitude form by 0 followed by 0 0 0, and for minus 0 also there is representation in signed magnitude form, that is 1 followed by 0 0 0. But 0 has no positive or negative sign, right? So this is the disadvantage in signed magnitude representation. That's why we are going to ones complement and two's complement representation. So is this clear?
क्लियर। भैया एक क्वेश्चन है,
Yeah.
जैसे कि ये एक्सेस 3 कोड है ना, तो इसका जैसे व्हाट इज द की फीचर ऑफ एक्सेस 3 कोड?
Yeah. Basically, it is used in encoding techniques. It is an encoding scheme. If we want to send any message through a channel, then we will use XS3 code is a one of the method to protect our data.
एंड अनदर कोई और भी एक्सेस कोड हो सकता है, जैसे एक्सेस 7 कोड या एक्सेस 6 कोड या 5
We will
कोड, जो भी
discuss
रैंडम
about in our upcoming sessions.
क्वेश्चन हो रहा है, क्वेश्चन हो रहा है
Yeah.
इसमें, जैसे कि इन हाउ मेनी डिफरेंट वे कैन नंबर 5 बी रिप्रेजेंटेड यूजिंग 2421 कोड?
So 2421 code number 5, right?
2421 कोड 5 कैन बी रिप्रेजेंट, या
2 plus 2 4 plus 1 5. Yeah, we have this type of questions also. I will poll. There are plenty of questions we can practice. 4 plus 1 5.
इसको सॉल्व कैसे करेंगे भैया, बस मुझे ये समझना,
Yeah,
सॉल्व
this
इसको
is
कैसे
2
करेंगे?
4 2 1. So 4 plus 1 1 1 5, and 2 plus 2 4 plus 1 5. So this is another representation for 5 into 4 to 1 code. And we have 2 plus 1 3. So that's it. There are two representations, I think. Have you got it?
फिर से एक बार बताइए ना, नहीं
So
समझ में आया।
2
जैसे 5, अगर
4
5 बोला है तो
yeah 2 4 2 1. So for 4 we are
या
writing 1, and for 1 we are writing 1. So 4 plus 1 5, and
5 या
2 plus 2 4, 4 plus 1 5. So we are making this as 1. So 2 plus 2 4, 4 plus 1 5.
ओके ओके
Yeah.
ओके, थैंक यू। या
So this is about today's session. So we will continue the rest in Saturdays, and uh, not Saturday. In Sunday we will take two sessions, and we will come. We will try to complete number systems. So this is. So if you have any particular doubts, you can ask me, or we can end this session.
नो, नो डाउट।
Yeah.